So this next step is about indexing. What is the purpose, what is the result or effect of creating an index to a table? Actually, when to create an index and when not. There are some rules of thumb also concerning indexing. And we are using this material created in a project called DB TechNet by Martti Laiho, Fritz Laux, Kari Silpi and Jaakko Ranta. Indexing is one of the most efficient ways of improving performance. It's not the only one. Just increasing the main memory is sometimes enough. Sometimes just putting hot tables to a different disk is enough. But many times you need efficient indexing. Finding out slow queries and then create an index for them. Whenever you read data from the disk containing the actual data in data files, these are stored in a so-called buffer pool. In this buffer pool you also have index pages, not only information from tables. And if you run out of memory, the least recently used idea is used, so the one that has been residing the longest in the memory will be thrown away and then new data is coming. So increasing main memory is one of the best ways of increasing also the performance of your database. So let's go through index technologies. And what is actually an index? There's a good definition by X-Open Group. An index can be thought as a list of pointers to the rows of a table. And they can be ordered based on the values of one or more specified columns of the table. I have mentioned this 3-star indexing rule, which takes from select clause first the parts in where, part of SQL clause, and then order by. And this definition also somehow reflects to the definition of this 3-star rule. Existence of an index may enhance performance by obviating certain sort operations or by reducing the scanning of the table that is necessary to build the result set. So the most time-consuming thing is going to the hard disk, find the different rows from different parts of the disk. And if they are not ordered in a way that you can fetch them in one fetch, meaning that you start and end, take a block, and then transfer that to the buffer pool and then operate on that, then it will take time. So if you think of hard disk and you are fetching data from different parts, it's going up, down, up, down, up, down, fetching, 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 fetching. That will take time. And sometimes even tens of seconds. And that's a lot of time. Slow query can be defined as query that takes more than 2 seconds. But you might think that even a query that is half a second, that might be a slow query. Because that time is typically taken from every other user using that system. And if there are 1,000 users, you are taking that time from everybody else. And creating an index typically reduces time to 1/10 of the time that without an index. That's a kind of rule of thumb again. And just for theory, you typically have a root page containing information or kind of pointers to the leaf pages. And then they contain information to actual table pages. And if you add a new key, and if there's not enough space in your leaf page, then you just add a new leaf page, leaf level there. So you split one in two and then further in small parts. And that is the trade-off having an index. You have to update the index table. This special space for having indexes. So the worst case scenario is a small table containing maybe only a couple of thousands of rows, which is updated frequently. So it's a small table and it's updated frequently, and if it contains an index, also the index should be updated. The best case scenario is that you have a big table which is not updated often and which contains information which is diverse, heterogeneous. For example, many kinds of surnames, many kinds of cities, whatever. So fetching data from this kind of data set takes time. Okay, then just the basic syntax of creating an index. It's just create index, and you give a name for the index, then mention on to what table, and then you just list the column names there. Very simple. You can create unique index. So it's like a primary key, that there are just unique values. Creating a unique index takes care that you cannot put same data twice, same data value twice in a table. And just remember that you should drop index, remove the previous index before creating a new one, if you want to test the effect of an index. All right, then just a couple of more things. It's about access methods. In this material, page 7, end of page 7. Unique matching scan, whenever you are using a primary key or unique key value, unique column in your page. So in your workflows, you are using a column that is unique, typically a primary key. So for example, this fetch will fetch only one row. Select last name and first name from customer table, where customer number is this one. Then range scan. So you have between and operations. And these are included in this scan. You can also use like operation. So it takes anything from up after this 9. Then concerning multi-column index, or also called compound index, is whenever you have 2 or more columns in the index. And concerning the naming of index, there are different kind of suggestions, some of them by Tapio Lahdenmäki. For example, you can indicate whether the index is made by purpose or not. Typically, you include in the name EIX, and then, for example, M for multi-column index. Actually, some of the database management systems do not force you to give a name to the index. But then you will have a kind of name for the index that you cannot know what the index is about. So if you include in the index at least name of the table that it refers, that helps finding and understanding what the index is. Some people even include in the name of the index also some kind of shortened version of the column you are referring to. So it might be index, cast, city, CNO. And what would be the best 3-star index, for example, for this one? If you take this rule of thumb, everything from where, then order by, and then rest of the select. 3-star index. We have index, EXM, cast, on, cast, and what are the columns and what order. Covering index or 3-star index. The rule of thumb. First, city, right? It's from where part. Then CNO from select. And include also last name and first name. There you would have 3-star index or covering index. What does it mean? You have everything from the select clause. And because index is like a table, so you are storing the values in index. You do not have to go to the table at all. You have data in the index. Yes, it is. But if your index contains all the information, then it does not have to use the pointers. So in this case, this index uses this CNO, and this can be used then in order to fetch last name and first name. So it's a pointer by using CNO to fetch the rest of the data from customer. So in that sense, yes, it uses the pointer. But if your index includes all the columns that are mentioned in the select, then it does not have to go and use these pointers. So that's the basic idea of 3-star index or covering index. So it needs to scan a table only if it does not contain all the columns. Then another concept called filter factor, FF. The smaller the filter factor of this value is, the better. If we consider, for example, this index from customer, city, last name, first name, CNO, and we have a query here where we are finding a city called München. What would be the field filter factor? It depends. If we are having customers mainly from Europe, then we will have a filter factor probably more than 50, which is bad. If we have customers from all over the world, so there are probably customers from Luton, maybe 10 also. And if we have 1 million customers, it's more than 0, so it's something like 0.001, the filter factor. So we would have, as a result set, as few rows as possible, because then that makes queries faster. Yeah, and actually the thing I mentioned is here. So this is one of the most important things in this material mentioned. So if I give you these basic rules of indexing, every database management system indexes primary keys. Well, there are exceptions, but most of the database management system index the primary keys. Many of database management systems also index automatically foreign keys. You should check from your system whether foreign keys are indexed. And then the next rule is thinking of having this covering index. So we do not need to access table pages at all. So if all the columns are mentioned in the index, it's a covering index or 3-star index. Clustering. Clustering index means that the system has created kind of a table containing this information which is mentioned in the clustering index. And there are different names for, so it's cluster index for DB2, clustered index in SQL Server. And Oracle uses cluster segment. So different names and a little bit different ways of applying the idea of clustering index. But it keeps rows on the same table pages corresponding to the neighboring index records. And they are, for example, ordered already in the way that you need to just take one part from clustering index and return that. Some of the database management systems support include. So you can make fatter the index. So originally we, for example, include only last name, first name, city, and customer number in our index, and then we would like to have also sex. So instead of dropping the previous index and creating the index again, we can include a new column to that index. And database management system is then using also this column in searching, fetching data. All right, I think we are pretty much ready to run our first experiment. Okay, couple of things still I want to mention. About the amount that index takes from your list, you can estimate the size, rough estimate, by multiplying number of records by 3 and taking also into consideration the total length of columns plus length of row ID. Row ID meaning the primary key. So if you have integer, maybe it's just 4 bytes or something like that, and total length of columns might be 2 gigabytes or whatever, and then just number of records 1 million, then you can estimate the size. Another thing, how to estimate how long does it take time to fetch data. And this rough estimate, even though it's not valid 100% anymore, because the speed of the disks have improved. We have SSD, etc. disks, so they are faster than previously, but this is still valid in a sense that you can get a rough estimate. Maybe divided by 2 now, by using the calculation. First, taking into account random touches. So whenever we do not know where the data lies in the disk, it's a random touch. So we need to fetch the data from, for example, from 100 rows. And when we have found the first data, if it's already ordered so that we can fetch the rest of the data from there, we have sequential touches. And then we are using also the number of fetch calls. So we might have, for example, 10 customers that needed to be found, and then information about these 10 customers, if they are ordered already, in a way we can sequentially read the rest of the data from these customers. So random touch, TR, sequential touch, TS, and then NF refers to number of fetch calls. And we multiply these with milliseconds. Random touch by 10, sequential touches by 1, 0.01, and number of fetch calls by 0.1 millisecond. We can get a rough estimate. Okay. Then just mentioning this, what does this mean? This just means that there is some value which you attach in this clause. Any value A, B, C. As you saw in MySQL, you have this @ mark, like variable, and then you have some value which is set to that variable. Yeah, there are a lot of terms here. Searchable, able to search is this word. And this is all. Yeah, just want to mention that there is a kind of basic rule how to create an index. This basic rule for indexing refers that first you take into consideration the where clause and create index for that. So not of this covering index or 3-star index. In the beginning, you start from where clause, and if that index is fast enough, then you should be happy. Not creating this 3-star index in the beginning. And how can you be sure if your index is good enough if you do not have the data? You can estimate it by using this cube, this calculation I just mentioned. Or of course you can generate data to the database to have 1 million rows or whatever. Some tools even have this functionality. For example, this, well, there are tools for that. You can generate data to the databases. And if it's not fast enough, then you add more data, taking these, and you can use this include statement to include order by and finally from select path, these columns. To find out how the database management system fetches the data, every major database management system has explain feature. This is how it is done in Oracle. So you just run a command explain plan for certain select, and it will explain. For example, it uses full table access. If the table is small or there is no index, it will read the whole table and scan it through. And if it contains 1 million rows, it might take 10 seconds or so to go it through. Okay. This is taken from SQL Server. I think Esa Salmikangas have shown this, right? This explain plan. Yeah. So for example, in this picture, we can find out that, okay, there is clustered index that it has been used. And you can have a rough estimate and even the real estimate how many rows it has scanned and what is the time, estimated time. Okay, estimated, even though it's done or run this query, it is always in a way estimate. And how many seconds in this case it has cost. Oh, are we ready yet? Yeah, there are some special things, for example, bitmap indexes, but I won't go through these now. So let's start doing things in practice. And now we are using this IBM TP tool. So it's page 23, Index Design and Performance Labs. The lab we are using is this one, even though it does not exist anymore. I have downloaded last year and now it is installed in this environment. It contains the IBM TP2 database Express C version by IBM and also this SUSE Linux version, Enterprise Server version 10. Note that the default name, username and password is TP2 inst2. These are used when we are logging in. And the actual exercise starts in a way from here, page 26. Starting from 26, there are these select queries, and we can try these out one by one. We just have to replace, for example, this average last name and average city, meaning that not the city or last name that is very frequent or common or seldom random, so that there are only few of them, but something between. And we can then estimate how long it will take from 1 million rows to fetch data, in this case just from one table. But how to connect to the environment? Yeah, that is the next step. So press Windows E in order to get the content of your hard disk. Go to the D drive, which contains 2 virtual machines, maybe more, but 2 virtual machines related to this database management course. And now we are using this DB2 Express C95 32-bit version. From the previous exercise, there are 4 log files. These LCK files prevent running the virtual machine. So you first should remove these files. You can select them and even press delete. We don't need them anymore. And the file we need is this DB2 C95 32-bit. What is the application that we need? It's VMware Player. I don't know if yes, so you should change the computer then. I think they installed this version in first 4 rows. Okay, so we have removed these log files. Next thing is run VMware Player. You can press Ctrl+S and write VM and then you should see VMware Workstation 12 Player. VMware Workstation 12 Player. Which looks like this one. Welcome to VMware Workstation 12 Player. Okay. Open a virtual machine. And the virtual machine resides in D drive. This DB2, and here you have it. And when you open it, it looks like this. And you just play it. If it does not work, then we can edit virtual machine settings. But it should work straight away. Even though it mentions operating system SUSE Linux Enterprise 789. I think it should work. In the material it was mentioned that it's based on version 10. And actually it is. It's here. Test the update. Update. Okay, it's about people and book timeouts. Can press OK. It takes some time to start. I think it takes maybe 3 minutes or so to start the virtual machine. So during this time, we can go further in the material. So do we need to, yeah. To return to your computer, press Ctrl plus Alt. Ctrl Alt. So you release the mouse so you can, for example, minimize this workstation. And then, of course, Alt and tabulation key, you can go back. But please do not hurry. It is quite slow in the beginning to run the virtual machine and take every component with. And back to the material. I shortly go through these exercises. So we can actually go step one by one here and just replace the content. But actually, before we are making these exercises or selects, we should be aware that there is no index before. And actually there is, because this virtual machine was created by using the previous version, the previous version of this course. I mean that I have already created the index there, and we should remove the previously made index. And this is mentioned also in this material. These examples here contain the actual select clause, then the fill factor mentioning how many. So for example, in this case, big city like London. In this case, it might be the fill factor of 10%, meaning that every 10th row is London by the city. Then concerning these letters, this P means that CNO, customer number, is a primary key. And it is clustered. And the other one means that we are using these as an index. Last name, first name, city. And how much time that will take, for example, in this worst case scenario, that we have a big city here, and also very common last name. The worst case scenario, by using this cube, QUBE estimate, is 11 seconds from 1 million rows. And if you divide it two, as I mentioned, that now we are having faster hard disks, it is still 5 seconds. Much too much. And that's before index. So actually there is only one primary key index, in this case the CNO, and no other index yet. Then another thing, the simple examples relate to only one table. In real life, we are fetching data from more than one table. For example, if we have 1 million customers and 4 million invoices in our database, and we are fetching data not only from customer, but also, for example, invoices, calculating sums, how much we have charged from different customers. In this case, for example, we are fetching just city from customer and invoice number and customer number from invoice. The worst case scenario is 150 seconds. So 1.5 minutes before indexing. But then we can reduce the amount of time by using indexes, and finally it might be just under 1 second to fetch. So from these 6 examples, we start actually from the page 34. Index Design Lab. Step 1A, 5 rows. Estimation by using this cube is 10 seconds. But before creating this index, we should remove the previous index. Or we can leave the index as it is and check what is the effect of index. The cube says it is 10 seconds, so how long does it take after this index? It's just, well, actually, because we have here several computers, some of you might drop the index and then create again. And some of you might want just leave the index as it is. So there is already this index cast x1 that is in place. But let's see. Now our virtual machine waits the username, and it was D. Okay, first click there. DB2 INST2. And it's the same as password. DB2 INST2. Again, it takes some time. And I save some time here to mention about this index. So create index. Which file do you have to delete? Okay, concerning this index, cast x1, it is on customer and only last name and first name are indexed. Percentage 3, 10, refers how much space is allocated free in order to add new rows to the customer table. It allows reverse scans and collect statistics about its usage. The rest, actually this is the mandatory part for creating index, and the rest is optional. But if we drop the index first, and then we create it again, we can estimate what is the effect of this first index. And in this case, we are using just last name and first name. Not the 3-star index. Last name and then something from first name, not the city or customer number. Okay, from this window, there's this one terminal window. We actually do not need that. And if you want to speed up writing the commands, you might want to drag and drop the file, meaning that you will save this PDF file. So you save it to your hard disk, for example, to desktop. I think I have it already there. Or not? No. And then go to the folder. And you drag and drop the file to this virtual machine. So this is the IDP Labs. Copy and paste, drag and drop. Should come. Does it work? Yeah. It's amazing that sometimes you need to just wait a moment and it will come there. And then double click. It contains also Acrobat Reader. So you should be able to open the document. And we are in a page 34. Yeah. Okay, it's playing with this window. I hope that you will get it right there. And where is the actual IBM TP2 database? You can find it from the control center. TP2 control center, double click. Takes a bit time. Again, I save a bit time here. Okay, it came here. Yeah, great. So this is the interface for control center. It resembles SQL Server, Oracle. So for example, if you click all databases and this plus sign, it shows that it contains DB2 index database. And when you click the plus sign again, you will see what tables, views, aliases, nicknames, etc. it contains. User interface is something similar with other database management systems. From these tables, we can see that we have two customer tables, CUST and CUST2. Then there are some explain tables containing these statistics. And that's pretty much all. Just two more tables for storing data from invoices. When you click once a table, you can see what columns it contains. So invoice table, invoice number, note, not integer, but it's character 8. Also, customer number is character 8. So it might contain these leading zeros there. Then there are amount in euros, date, and like a reference information, also character. And invoice table contains, customer table, it contains last name, first name, then about sex, city, customer type, and address, phone, and then there are some couple of dummy columns. Does customer have indexes? One way of finding that out is right-click the table and here, for example, command show related. Show related. And if you click indexes, you can see that, okay, here is customer primary key, but nothing else. Okay, that's nice. It seems that I do not have this index for this customer. Not yet. Do you have? No. You have similar situation. Fine. So we can start from scratch. So let's close this one and go to the query view. How do you make a query? One way of doing that is clicking with your right button of your mouse the database, and then the first command is actually query. And now you have a command editor. It contains 3 tabs: commands, query results, and access plan. And from these commands, you write the SQL command here and then run it, meaning execute, or execute and show access plan. We are mainly using this one in our queries. So we do not have to drop the index, but if you should drop it, you just write drop index and name of the index. And if you have this PDF file, you can go there and copy and paste the commands from that one. So what was the first step? Again, we might want to first examine the result without the index. So just take this select clause, copy and paste it to your query. Or write it. Select CNO fname address phone from cast where. And I rely that there is this kind of last name, lname 287 and Truro as a city. Control C and paste, Control V. And now you click this tool, execute and access plan. You also see a rough estimate of time. Okay, it returned 5 rows, as it was in this material, 1A. Okay, by using the database db2ins2 and customer table, it scanned the table, sorted it, and finally returned the data. And the total cost, timer ons, was 111. And what does this mean? These are milliseconds, so it is 0.1 second if I calculate right in seconds. Actually, you should check what is the value in your database management system. What does this number refer to? Is it milliseconds or seconds, or what is the unit? So, but this fill factor, it seems that these examples are referring the actual database. You can leave the previous result there, or the previous command, and take then the next command. And now actually we should create the index. Index to our database. So this create index command. Something that I should also mention, that whenever you fetch data from database, as I mentioned actually, it's in buffer pool. And how can you be sure whether your index is used or if your buffer pool is used? So it might be that the data is residing in the main memory, in this buffer pool. And why use index if it's already in the memory? And memory is so fast. So actually, in order to test the effect of an index, you should restart database management system again and again. So before and after. So, or some kind of having this flushing of memory, removing previous data from memory. But okay, let's copy this index command and put that to our system. Control Center and paste it here. Is there a similar system here as it is in MySQL Workbench that you can select and run? Yes, it seems so. Creating an index to a table that has 1 million rows takes time. It depends on the database management system, but typically it's several seconds creating this kind of index. But okay, we managed to create the index. And then we run this select that we had again. And of course we can click the execution plan. Same result, but as you can see now the execution plan is different. It uses this index plus x1, and if you compare the value, it was 111 and now it is 4. That is the value that you should compare. So this is how much? "25 times faster," or something like that. This number is, if you compare it to 111, something like 25 times smaller than the previous result. What we can get from this one? First, if your customers, users complain of slow queries, you should check out what are the fetches, what kind of queries they are made. What is the select clause behind? Then you start from checking the where clause and take from the where clause those columns that you think that affect the query. For example, if your query usually contains Helsinki as a city, and your database is mostly about people from Helsinki, you might leave that city away, because that kind of index does not affect the speed of the fetch to select so much. You might contain only, for example, last name, as we did in this case. Then from order by, you take columns from there, because then it's already ordered. The index is ordered the same way as is in the select. And finally, you might consider having from the actual select part the columns. And if your system supports this include, you can of course include those columns. If not, then drop the index and create it again. And actually, rest of the exercises are more or less versions of that. Just adding something more on this case. Let's just take another example. I will put this one here. This is slow query, or would have been before indexing. Would you like to test it? So drop the index, run it, then create the index and run it again. So you can compare before and after. Or you can just rely on that this query is 10 times slower than the previous one. So by using this rough estimate, we can estimate that this query is 10 times slower than the first one, meaning that it would be something like 1,100, the cost estimate for the query. How slow or fast is the query now after indexing? I put it here, select it and run it by using also the access plan. It is slow. Adams is the most common name in the database, and the city called Big City is, I think, the most common city in the database. Yeah, it takes time. We do not have city in our index. We have just this last name and first name. So even though it uses the index, so it helps fetching the data, it still is time consuming. So total cost is 33,000 in this case. How can you make it faster? So what would be your solution? Let you think it now for a moment. What kind of index you would create for this slow query? So in order to test your new index, you should now drop the index you have created. If you have several indexes, you might not find out what is actually the best way of defining the index. Sometimes the system uses one index and two indexes on one query. But usually it is best to just create a new index containing more columns. So now you should add city in your query. And actually, yeah, whether to put city before first name or not, it partially dependent on how do you use this city. I would estimate that putting that before first name, so it would be last name, city, first name, would be the better option. Because taking this rule of thumb, taking first the where part and then order by part would be better. But okay, you can test and compare. So some of you might want to change the order on this index. But first let's drop this index x1. So commands, tab, go there, drop index, select, run. and then create this index. I will change the order, but some of you might want to have this previous one, so we can compare the result. Select, run. Now it should take more time because we have more columns on our index. I think previously it took only approximately 5 seconds, but now it was nearly 20. And then, what was the query again? I think it's the same query as before. So we can go there and select the previously made query, and again execute an access plan. Yeah, it was much faster. And if you compare the result to the previous one, it was 33,000 and now it's 3,000. It is 10 times faster. Just to include CD in our index. Okay, sometimes it happens.
It took 1.5 minutes and nothing.
Okay,
Now it's not responding at all.
so close the machine, virtual machine, and yeah, you might need to do that. Power on. So it will take 1 minute and then start again.
Now
It sometimes happens.
Now it's doing so everything that is well and on time. We care about results.
Not yet. So the idea is that if your query is still not fast enough, then you add more columns. Either by using include or you drop the index and create it again. That's the basic idea. Why so? Why immediately make a 3-star index? Because updating index takes time. So we do not want our index to be too, how do I say it? Too improved in a way. We do not want to play safe just for queries. We need to think of also inserts, updates, and deletes. So whenever there is an insert, update, and delete, it also affects the index.
And how often should I update the index? Is it updated automatically?
It's updated automatically, but actually this is a very good question. You should reorganize index maybe once a year. Reorganize index. Because index is also fragmented during the time. One of the reasons that when we created this index, there was this mentioning also percentage free, as it is in tables. So you can estimate how many new rows will come also to this index file. So now it contains this 1 million rows, and you can estimate that there will be maybe 100,000 during the next maybe couple of years or so. But reorganizing index now and then, maybe once a year, that's something that you should do.
Just drop it and create again.
That's one way of doing it. Or there's typically reorganize command in database management system. Yeah, I think that completes at least one session that I have been recording. So we have learned that by creating an index, we can really improve the performance of queries. And not to create index immediately by using this 3-star index or covering index, but just step by step, checking when it is fast enough.